Chapter 7 test. Let's go over this. First of all, the thing you should do is go through each of the first 5 problems and decide which of the 5 methods you're going to use for each. By first just looking at what you could do with each. For example, this one, substitution. Could we do substitution on this one? Let's see. If we let u equal x squared minus 1, du would be 2x dx, and so dx would be du over 2x. So substitution would work on this because this x would cancel that x, and this would be a pretty simple one to do with substitution. So it could be done with substitution. Could it be done by parts? Well, maybe, but we didn't do much of that, and we'd be taking derivatives or integrals of square roots. Not pretty, so probably not parts. Could it be done with partial fractions? Well, with this root on this, yes, this factors, but it's not really a partial fraction type problem. Could it be done with Trig substitution? And this one probably could be done with Trig substitution, since it's got a square root and it's got stuff in here. And so I would set that up by saying, since the x squared is the positive and that's the negative and it's a subtract, I'd put it over on the opposite leg of this, and I'd put an x squared minus 1. The square root of x squared would be x. Square root of 1 is 1, and that's how I'd set that up. And I would say, see, 1 over x is the secant of theta. X over 1 is the secant. 1 over x is the cosine. X over 1 is the secant, so x. Find the derivative. Derivative of secant is secant theta tangent theta d theta. And the derivative of x is dx. And the square root thing would be over 1. That would be opposite adjacent. So the tangent of theta would be the square root of x squared minus 1. And we can make the substitution of tangent for that and for the x secant. And we could go about doing that. So it's possible to do this one with trig substitution. With substitution, not really, we don't really have a formula on our tables that match this. So this has got a couple of good options. Which one are we going to do? Well, let's find out later. Let's go to the second one. How about substitution on this? Well, the messy part's that denominator, so if we let u equal x squared minus 3x minus 4, du would be 2x minus 3 dx. Ooh, that would go under du. Ooh, that matches. So this one would easily be done with substitution. Could it be done by parts? Not really, because it's not the kind of stuff we've done before. We might be able to, but it'd be forcing it. And we're looking for 2 things multiplied usually when we're doing that. We could bring this up and call it to the minus 1, but it still would be ugly. Partial fractions. Does this denominator factor? Let's see. That would be x and x. And we'd have to get a minus 4. We could either do 2 and 2 or 1 and 4. And I think 1 and 4 will give us a 3 if they're subtracted, which that minus on the 4 says they are. So we'd probably go x minus 4 and x plus 3. So we would want to change this into a over x minus 4, for instance, plus b over x plus 3, and figure out what a and b is so that it comes out to be 2x minus 3 when we get common denominator. So this one looks like it'd work for partial fractions. Trig sub, you might be able to complete the square in the denominator. Here, let's see what that would look like. We'd have x minus half of negative 3 would be negative 3 halves squared. And then, so that squared would be 9/4, or 9/4 is 2 1/4. This would create positive 2 1/4. To make them 4, it would be minus 6 1/4, which is, I think, let's see, 5 times 5, 25 over 10, or 2.5, 2.5 squared. I think that's right. Let me think here. Take a quick look. Yeah. So this would be 2.5 squared. Well, that's looking like it would work for a trig substitution where we set it up with this would be minus, and so we'd put it over here. This would be x minus 3/2 squared minus 2.5 squared. We'd put the x minus 3/2 here and 2.5 here, and we could do trig substitution on this one. Now, nobody tried it with trig substitution, so I will not do this one with trig substitution here, but it is possible to do this one with trig substitution. Formulas, that we don't have formulas in this particular table. There exist formulas for this kind of stuff, but no. Okay, let's look at the next one. Substitution. Well, if we let u equal this, we're going to get 8 du would be 8x dx, and we don't have an x to cancel. And some people tried to cancel that x. That's not there. We're replacing that with du over 8x. So we have this x showing up that would be a problem. So this one's really not a substitution problem. By parts, well, we would have to put this to the -1 and do that. This is not really a by parts problem. Partial fractions, this doesn't factor, so it's not really partial fractions. This one pretty clearly could be trig sub if we do, see, these are added, so we'd put the square root, even though this doesn't have a square root, we'd put the square root of 25 plus 4x squared, and put maybe 2x here and 5 here. So that squared plus that squared, square root goes on the hypotenuse. So we would have the simplest for x would be tangent, 5 tangent. Theta would be 2x, because opposite over adjacent. 2x over 5 would be the tangent, multiplied by the 5. Take the derivative, we'd get 5 secant squared theta equals 2 dx. Oh, I forgot the d theta. And so I'd have something to replace the dx with, this over 2. And what would I place this with? Well, the square root over 5, that would be hypotenuse over adjacent. That's the reciprocal of cosine. Secant of theta would be the square root of 25 plus 4x squared over 5, which I'll put here. So to put something in for here, I would have to square this and square this to get rid of the square. So that's what that's the trig sub. Tables, formulas, we don't have them for this. So this one's really kind of restricting me here. It's saying we probably need to do this one with trig sub. Now there's other ways to do it, but boy, this one really says do trig sub on me. Okay, this one, we do have a product of two functions. Now, you might be able to do something with substitution, but that's not really when you have a product of two different functions like this. It's more like by parts. This is not a partial fractions. It doesn't have a denominator that we're trying to split up. It doesn't have a square root or a quantity squared plus a quantity squared or a quantity squared minus a quantity squared. So it's not trig sub. We don't have a table for this. So this one's begging you to do by parts. And normally we let u be the x squared so that when we take the derivative it gets simpler. Except when we have ln. And I've said this several times, and some of you must have been on vacation when I said that. This one is where we would let u equal ln 3x. So that du would be, the derivative of ln is 1 over the quantity times the derivative of the inside, which many of you who did this with pi parts forgot to put the 3, dx, the chain rule. And on the what's left is, for the dv, is x squared dx. So we integrate it, not take the derivative, and so v would be integrating x squared. The antiderivative would be x to the third over 3. So this becomes, I'll go ahead and finish this one because we're there. This is the only one we can do here, and I probably should go back and finish that one. So let's go ahead and do this one right now. So uv, which would be x cubed over 3 ln 3x minus the integral of v x cubed over 3 du, which these two 3's cancel, and it's just 1 over x dx. And this x cancels one of these and makes this turn into x cubed over 3 ln 3x minus the 1/3 can come out. And we'd have x squared in, and the integral of x squared is x to the third over 3 plus c. And you can make this x cubed over 9, or you could factor out a third. But that's it. We're done with that one. Let's go back and do this one. Since I'm on this page, since we're probably going to do this one with trig sub, then we'd have the integral. It would no longer be from 0 to 1, so we got to put question marks there. Not 0 and 1, because we're changing to theta. And dx will be replaced with 5 secant squared theta d theta over 2 from this. And the square, this thing is that quantity squared, and so we're going to have in the denominator, where that is 5 squared, which is 25 secant squared theta, and that's it. So the secant squareds cancel. One of these 5's cancels this and makes that a 5, and so we get 1/10 we can pull out, so we have 1/10 the integral of just d theta from question mark to question mark. And when you integrate it with respect to theta, you get 1/10 theta. And since this is a definite integral, we'll put that. Now, I didn't change the limit, so let's just go back and figure out what theta is. Let's see. To solve for theta, I'd have to divide by 5 and take the tangent inverse. So it'll be 1/10 tangent inverse of 2x over 5. And now I can say evaluated from 0 to 1. And so I get 1 in here is negative tangent inverse of 2/5, so I'd have 1/10 tangent inverse of 2/5 minus, and if I put in 0, I get 0. And the tangent of what angle is 0? It's 0 degrees, 0 radians, and so that times the 10th is 0. So my answer is simply this. You can put that into calculator and you get 0.03 or something like that, but this is good enough. So this page is done. Let's go to this last one. What haven't we done yet? Tables. Is this one good for tables? Let's see, substitution. Yes, this one can be done with substitution. We got sine to odd power, so we could let u equal cosine x. And do this, then du would be derivative of cosine is negative sine of x dx. And then we can divide by sine x to know what to put in for dx. And so this would become the integral of sine to the 4th x du with a negative, because I'm canceling out one of the signs. So I can pull the negative out, but I got x and u, and I can't have that, so I have to figure out what to do with that sine to the x. Well, if u is cosine x, then u squared would be cosine squared x, and 1 minus cosine squared is sine squared, so sine to the 4th would be 1 minus u squared, that's 1 minus cosine squared is sine squared, and I'd have to take it and square it again to the 4th du. And I could multiply this out and do all that, but I haven't done a tables one yet. So I'm going to look at the tables and see if there's a way I can do sine to the 5th. And on the tables, it says right here, if you got sine to the 5th, you can get it down to sine to the 3rd. And then you could take sine to the 3rd and get it down to sine to the 1. So formula 2 would help us do this one, and we wouldn't have to do much of any thinking. So this, the integral of sine to the 5th of x dx, in this, n would be 5. So I'd have minus sine to the 4th x cosine x over 5 plus 4 over 5 integral of sine to the 3rd x dx. And might as well do the table again. Now, some people said, oh, I'm just going to integrate sine to the 3rd and call it cosine to the 3rd. No. When the power's on there, the integral of sine is not cosine. You'd have to use the power rule. It would be sine to the 4th x over 4, but then there would be divided by the derivative of sine, which is cosine, and that would not, this is way messier than what we got here. It's not going to work to just integrate that straight, like some of you tried to do. So I'm going to move this down a little bit here. I think that'll work right there. I'm going to leave this part, negative sine to the 4th x cosine x over 5 plus 4/5. Now, this is what I'm looking at. And so on this, n would be 3. So I'd have minus, looking down here, sine to the squared, is to the second one, less x cosine x over n, which is 3 now, plus 2 over 3, and you can see my pen's dying. Let's hope this one works. Plus 2 over 3. integral of sine to 2 less than 3, which would be sine of x dx. And so we have minus sine to the 4th x cosine x over 5 plus 4/5 times a negative sine squared x cosine x over 3 plus 2/3 times, well, the integral of sine is negative cosine, plus c. You could have left it like this, or you can multiply this in here and you get negative sine 4th x cosine x over 5 minus 4/5 4/15 sine squared x cosine x minus 4/5 times 2/3 is 8/15 cosine x. And there's a cosine you can factor out. There's a 1/5 or a 15th you can factor out. You can do some things with that, but this is good enough. This shows me that you know how to get it integrated using the table. Okay, so now let's go back. We now have a table one. We have one that only works with parts, or just about only works with parts. And we have one that worked with trig subs. So now we haven't done partial fractions or substitution. So back on the first page, we've got one here that could do substitution, but it does partial fractions. This one doesn't. So this one we probably should do with partial fractions. And this one we should do with substitution. Let u equal this. This comes to that. So we'd have the integral. If you use that, it's 2x. We got 5x. dx is going to be replaced with du over 2x. And we'd have the square root of u. The x's cancel out. We can pull out the 5/2. This is u to the negative 1/2. The square root is the half, and it's in the denominator, so negative. du, using the power rule, we have 5/2. Integrating this, we add 1, which is u to the 1/2 divided by 1/2. And u was x squared plus 1, and this is the square root. So and the half times 2 would cancel. So we have 5 square root from the half of x squared minus 1 plus c. This one. Okay. To get a common denominator here, since this factored to this, we put a over those. Those are just linear factors. This would have to be multiplied by x plus 3. And this would have to be multiplied by x minus 4. And we could do, let x be minus 3. We could let x equal 4. But we'd have, of the x's, we have 2x's equals ax's plus bx's, so we'd have that equation. And the other one, a minus 3 is equal to 3a minus 4b. And, let's say I wanted to get the a's to drop out, or the b's to drop. Let's just multiply by 4, 4, and 4. These would cancel. You could also solve for a and substitute. You could use matrices anyway. What you would get is, if I multiply by 4, I get 7a equals 8 minus 3, 5. Oop, that doesn't sound familiar. What did I do wrong here? 2x minus 3 over that denominator, x minus 4, x plus 3. So that's through ax plus bx equals 2 x's, and minus 3 is equal to 3a minus 4b. If I multiply by 4, 4, and 4, I get 8 minus 3, 5. I got 4a plus 3a is 7a. So a is 5/7. Why doesn't that sound familiar? Let me look at my key for a moment. I feel like I'm making a mistake somewhere here. Oh, why did I put 3? This factors to x minus 4 and x plus 1 to make 3. 1. There's the problem. I knew there was something wrong here. Didn't sound right. Dang, I factored incorrectly. I apologize, and I messed that up in the video earlier, so bear with me. So this should be a 1 and a 1. So it'd be, this is right. This would be 1a and minus 4b. So if I multiply by 4, I'd get 4 plus 1, 5a equals 5. So a equals 1. That's right. And if a is 1 and a plus b is 2, b must equal 1. So this changes to the integral of 1 over x minus 4 plus 1 over x plus 1 dx. And the integral of this is ln of absolute value of x minus 4 plus ln, the absolute value of x plus 1 plus c. Okay. Silly mistake. Okay. Not doing too badly today. All right, the last two. The first thing on these is there's a point, one of the limits that's a concern. The tangent of pi over 4 is 1, so that's not a problem, and secant of pi over 4 is doable. Pi over 2, tangent of pi over 2 is undefined. It goes to infinity. So we need to rewrite this with a limit, and I need to see the limit in there as r or b or something goes to pi over 2 of the integral r and pi over 4 of secant squared x over tangent squared x dx. And there's several ways to do this. Some people simplified this and got cosecant, and the integral of cosecant is cotangent. That is probably the easiest way. Another way would be let u equal tangent theta. Then du would be secant squared theta d theta divided by secant squared. And we'd get the limit as r approaches pi over 2 of the integral question mark to question mark, because we're changing the variable, secant squared x over u squared du over secant squared x. Those cancel. And this becomes, that's u to the minus 2, which is not an ln thing. You integrate that by adding 1 to the power and dividing by what you get. So we get limit as r approaches pi over 2 of u to the minus 1 over minus 1 from something to something, or the limit as r approaches pi over 2. I'm going to rewrite this as minus 1 over u, minus 1 over u, evaluated now back to pi over 4 to r. And then you need to plug in the r into this before you do the limit. And so we'd have the limit as r approaches pi over 2 of minus 1 over tangent of r. And 1 over the tangent is not tangent inverse of r. It's the tangent to the minus 1 power. That's true, but not tangent inverse. Some of you did tangent inverse. Not good. Minus a minus, which would be plus, and put it in the pi of 4, 1 over tangent pi over 4. And now you take the limit. Tangent of pi over 4 is 1. So 1 over 1 is 1. The limit is goes to infinity. That's still 1. Tangent of pi over 2 goes to infinity. And if the denominator goes to infinity, the fraction will go to 0. And so this would be 0 plus 1, which is 1. So it converges on 1. Okay, final problem. You could do, I saw people do integration by partial fractions on this one. That's fine, because that factors to x plus 2 and x minus 2. But this is a pretty simple u substitution. U equal x squared minus 4. And the 2u would, the two x's would cancel. The x in there would cancel. But where's the problem? Is it with the 1 or with the 2? 2 in here makes 4 minus 4, which is 0. You can't divide by 0. So we have to write, this is going to turn to the limit as r approaches 2 of the integral, and I'm doing a substitution, so the limits are going to be changed. Let's go ahead and change them this time. We're putting an r in place of the 2, so it'd be r squared minus 4. And for the 1, that'd be 1 minus 4 is negative 3. And this would be 3x dx is du over 2x. And this was my u. The x's cancel. So I get the limit as r approaches 2 of, see, the 3 halves comes out. That'd be 1 over u, so it's 3 halves. 1 over u is ln u, evaluated from negative 3 to r squared minus 4. So before you do the limit, you got to plug these in. I want to see that step. This is going to be the limit as r approaches 2 of 3 halves. That could actually be pulled completely out to here, but I'm going to leave it there. ln of r squared minus 4 in absolute value minus 3 halves ln in absolute value minus 3. And that becomes 3, and so this is a value we can get. There's no r in it, so we can find the limit of that. But this would cause this to go to 0, which the ln of something approaching 0 approaches negative infinity, and so this one, this part blows up, diverges, and so this whole thing therefore diverges.